All right, I'm gonna get started. Let's see. Okay, I have never used kicad before or any PCB layout thing, so I'm just making shit up as I go. But what I want to do is give myself a sort of visual aid for the holes in the perf board. So I'm just drawing circles on a user layer, user.2. So we have a grid. I think that should match the dimensions of the perf board. We have 6 rows and A through Z. And AB, but it's missing W for some reason. Swedish alphabet. So yeah, 27 columns. I have started to transfer the schematic. Hey Yore! Congrats on the first. So I've started to enter the schematic into kicad. And I have no idea what I'm doing, so kind of just have to figure it out. I think I need to set a footprint for every single item that I have. So here on the input filtering side, we have a 330 nanofarad capacitor. Let me quickly see if I can find the package where I have those. Yes, okay. Found it. Not designing a circuit board, I just want to help myself put them into reasonable spots on the perf board. My plan is still to use a perf board, but I don't feel comfortable just placing them ad hoc and then figuring out that the connections are crossing in crazy ways. I want to have a little bit more organization in it. Okay, so 330, that's these. Let's just measure the footprint. So the distance between the legs of the capacitor is about 5.5 millimeters. Actually, let me see. Does it align with? Okay, yeah. So it's 2 holes apart. That's cool. And what about these? These are not as straight. But I guess this could be, yeah, this is 3 holes apart. That lines up nicely. You know, having one of PCBs etched is surprisingly cheap. I know, I know. One day I will probably graduate to that. But also, like, yeah, getting PCBs, I would have to order them not from ElectroKit, where I normally get all of my components, because ElectroKit makes that very expensive, like hundreds of euros for a single PCB. Which no, that's I don't know who even uses that service. But I know that you can order them from other sources. Okay, so yeah, that's crazy expensive. Actually, can I show you? Yes, I can. So ElectroKit, they have this manufacture of PCBs. 160 by 100 millimeters costs almost 200 euros. I mean, okay, that's fairly large, and it's a single layer. If you go to double layer, it's whoo. But I wonder if I were to, because this is what this is 2 by 8 centimeters. If I were to go 30 by 7, 3 by 7 centimeters, it's super familiar song. Is it from a game? I haven't. This is from Pretzel. It's what Pretzel is showing in chat. But yeah, so this is what it costs from ElectroKit. I really don't understand why it's so crazy expensive. I don't recognize the song, honestly, so cannot really answer that question. But yeah, so we need axial. Monster card sounds about right. Right. If it's actually the size of a motherboard, sure. Yeah, but even if I went for 3 by 7 centimeters, it was the same price, which I don't understand. So what are these dimensions, I wonder? Okay, so the first number seems to be length. Pin pitch, 15 millimeters. Okay, length. Wait, I don't want to. Oh. What did it. Wait. You saw on a YouTube channel that picked top songs of Newgrounds. Oh, okay, cool. What do all these terms mean? I don't understand. Yes, I want the length to be about 5 millimeters, I guess. Yeah. So there's pin pitch. Right. Radial. Oh, okay. This should fit. This should fit, yes. So we actually want, okay. I'm gonna use a disk footprint or rectangular footprint. Oh, rectangular footprint, that will do. Cool. With 2 millimeters, yeah, that'll do. Length. It doesn't perfectly align with a inch-based hole spacing, but this'll do. This'll do fine. Okay, how do I select this? All right, cool. Now for the 100 nanofarad, I want capacitor 7.5. Millimeter. There we go. For the voltage regulator, we do have a footprint. For this, do we have it? No, we don't have a footprint. So we want a connector Molex style? No. Oh, KK should, yeah, KK will, I think, fit. 1x2 or... Pin header. Oh, pin header. Vertical pin header, 1x2. There we go. This is what we want. Yeah, German. Okay, so for this, we want, I'm not representing the full Raspberry Pi, but I want 1x10 pin header. Is this a remix of some DNB song? I don't know, some DNB bot, rebut of a DNB bot. Nice one, bot spot. Actually worked really well. I don't know, I've heard this song on Pretzel a bunch. A rebuttal, yes. Okay, and for this, do we have a footprint? No. So that's going to be a pin socket 2x3, 2x03. Pretzel is acing it bot day. Let's go. Okay, let's see if I can... Okay. Wait, what? There's a lot of errors here. J2 pad 11 to 20 not found. Wait, what does that mean? J2 is the Raspberry. Okay, what? What? Okay, can we rotate? Okay. Wait. Oh no, okay, that's wait, why is this not lining up with There we go, now it's lining up. Yore is acing it today. Let's go. Yore is acing it every day. Okay, so wait, how do I drag this? Oh, wasn't selected. There we go. Okay, so now I just need to reproduce the rest of the schematic. I mean, it's not that much. And place it on this I probably don't want to have it. Let's put it about there-ish. Okay. I will figure this out. So wait. Oh, now I know why the errors, because the Raspberry Pi actually has 20 pins, not 10. So it's supposed to be 1 by 20. Ha ha ha. That makes a lot more sense. Okay. I also need to renumber them. Um... Mm, how do I rename this thing? So is there a pin layout for 10, or would the program been okay if you had 2 sets of 10? Wait, what do you mean? I'm not following. How do you... Can I... Huh? Oh, okay. This is how. Raspberry Pi doesn't have 10. Oh, yeah, no, because... So, yeah, the problem was when I assigned the footprint for this, I assigned a 10-pin footprint, but it's a 20-pin header in the schematic. So that's why I was complaining when I tried to transfer it to the to this. It was complaining that it couldn't find 10 pins. That's because, yeah, I had the footprint assigned wrong. Wait, I should actually, okay. I should put the power delivery on this side of the perf board. So why did it get misaligned? Oh, now it's aligned, okay. I'm a little lost, but perhaps there's some more intelligence in the software that I'm not aware of. No, it's quite simply that in the schematic I have a 20-pin header here, right? So it's this is one element, this whole thing, and you have to assign a footprint for those. But how did okay? And the footprint is the thing that I was selecting here. Footprint defines the physical dimensions and constraints of it. But like, so logically it has 10 pins. It has, it's a 10-pin, or not a 20-pin header, right? And I assigned a 10-pin footprint. So for 10 of those 20 pins, it couldn't find a physical layout or a physical object to connect them to. All right. So yeah, that's all good.
Hello there.
Hello, Camila. Welcome, welcome. Is the music a little loud? I figured we can listen to the industrial playlist since I'm doing industrial things, right? Think about a stretch in the posture check. I'm also gonna hydrate. Nerd stream, yes. You being giga nerdy today. Should actually do my nerd things too. What kind of nerd things? But yeah, so then we have wait, what? I was able to change things by double clicking before, and it doesn't work anymore. Why? Also, why is it selecting? Why is it misaligned from where I'm clicking? What? Huh? What's going on here? Also, I can have these two things. Haha, side by side. Kamilum lum. Need to go measure my car speakers in the mountain. Right. An interesting end from a workday. Weather made our tramline inoperable again. Oh no, what happened? Yeah, weather. Okay, so I can change the properties in the. Why can I not do the same thing here? What's going on? It's freezing rain. The Canary line would freeze over almost immediately. Ice is a horrible conductor, so the trams could barely move. Oh, gotcha. Yeah, that's not fun. Okay, I'm gonna restart the editor. No, it's still. I don't know. Is it a question of what tool I have selected? Edit. No. No, this is not what I wanted. For us, it's fine. We're just there to maintain them. It's a rough day for the traffic controllers. Yeah, I bet. I'm so confused right now. I really don't understand what's happening. Why am I unable to change the properties of an object? It works for this one. Works for this one. Works for that one. Okay, I can do it for the global thing. Ah, okay. Can I change the number? No. Wait, what? Edit symbol. No, I don't want to. You still near a super sharp curve on a super steep hill. Trams were literally getting stuck there whenever weather happened. Aw. No, not what I want to do. Okay. Properties. Oh, help. Why is it not possible to change this? I want to change this. Give me a way to change. Okay, well. fuck this. I don't care. I'm gonna have to... Okay, we have 5 volts. 5 volts is connected to pin 39. It would be really useful to be able to actually name things, but... Ah, boy. Wait, what did that just do? Oh boy. It's all going horribly wrong. I... Like, I really don't understand why it's impossible to change the names. Oh, boy. Uh... So then pin... All right, I need to add a header. Oh, what was this? Okay, so I can edit the labels and things on that, but not on the individual pins first. Okay. So this is connector. Okay. Don't remember anything. Yeah, that's fine. Thank you for the work. Yes, good luck with the laundry. So we need to connector 3-pin. So this is gonna be the duty cycle potentiometer. We need to select a footprint for it. So 1x3 vertical. Yes. So that's connected. Okay. 36. 34 and ground. There we go. Um, 38 is ground as well. What else? Yes, we need a connector 1x4, or actually, okay. So this is gonna be the fan header, footprint. That could be a Molex KK. Yeah, let's go with this one. It's not an exact fit because the fan header has a slightly different layout where the fourth pin is kind of separate. So what I'm actually gonna do is use a 3-pin Molex and one more pin next to it, just so it fits, but that's fine. Actually, let me quickly... Do I remember you not knowing much about electronics? Do I remember wrong, or do you have some... Must be misremembering, because I used to tinker with electronics as a kid. I've never used never used tools like this before though, so... Okay, pin 1 is ground. Wait, how do you flip? Mirror vertically, okay. That's ground. Pin 2 is 12 volt. Um, let's just move this out of the way. Wait, what just happened there? This is not supposed to be connected that way. Oh right, this is the original version. But yeah, so the other one was actually a remix, I guess. Wait, when did I connect pin 15? I don't remember doing that. Pin, or, well, 25, 35. That's not supposed to be connected to anything. No. Okay, and these are connected, so pin 3 of the fan header. Okay, pin 4 is directly to 27. Mm. And pin 26 is going through a MOSFET. Wait, what MOSFET do we have? VN10K. Was it? Let me quickly double check. Yeah, it's VN10K. Uh, yeah, I suppose I can just pick anything that's TO92 because uh, the one that I'm using is not here. So, VN10K, nah. TO92, yeah, okay, sure. So, Welcome back. Oh, what's up? Cheers. I'm pouring into myself this pink liquid. So the gate is connected to 3v3. And 3v3 is this here. So move that a little out of the way. Think I'm gonna have alcohol later though. Nice. What kind? How about an idea to try to build a 3x4 calyx? Wait, which one is calyx now? Oh. 3x4. I don't know. If it was me, I would probably just go for it. So, Sienna. Sienna means hi. It's not taller than me. But yeah, I would advise against having alcohol before for safety reasons. Okay. Drain is connected to 3. And also we have a resistor. So that's a 10K resistor through hole. It's a chunky one, unnecessarily, but so it's axial. How long is this one? Okay, this one is 8.5 mils long, so I guess I would need the holes to be maybe let's go for this footprint. Diameter 3 mils. Does it roughly fit? 3.2. Ah, well, give or take. This'll do. Okay. So that's connected to plus 12 and to the drain. Did I make 1 ohm resistors? Yes. You have alcohol now? Oh, what do you have? Probably sponsored by my mystery neighbor. Someone keeps throwing away plastic bottles that have a deposit on them. Really, checker bins as I walk past. Nice. You're less tiny than me, and my back is exceptionally bad. I get that. I get that. I mean, I don't know. Amazon has 1 ohm resistors with 1% tolerance, an amazing tolerance, honestly. Yeah, they're actually specialty resistors with extremely high precision. And those are like there are legitimate applications for right. So one application for low resistance resistors or low value resistors is ouch, what happened um, in current sensing circuits where you would have you have a line with voltage. You run and you have a load, and then you put a resistor that's like 0.1 ohm, for example, and then you get an IC that measures the voltage across that resistor, and it's able to determine how much current is being drawn by the load. That's commonly used in buck converters or overload protection and so on, overcurrent and overpower protection. So they didn't think of that. Yeah, this is the thing that's commonly done in it's done a lot inside computers, where you have different power rails, and the power regulation circuitry needs to know what load is being drawn on each rail. Epic cardboard cut from the box Exxons. Oh no. Should have picked something less nasty. But yes, so that is one application of very low value, very high precision resistors. Because like if the sensing circuit knows exactly what voltage is supplied here, then from on the power rail, from the voltage drop across the resistor, it can very precisely determine the load. Yeah, it is pretty neat, and it's a very, very direct application of Ohm's law. Wait, what did I click here? Okay, and the source is connected directly to pin 26. And then finally, we have the OLED display. I was just thinking 1% is a combination tolerance with resistors, but that's when we talk about hundreds or thousands of ohms. 1% tolerance on 1 ohm is, yeah. Long drink. Continue with cheap beer. Nice. Enjoy. Cheers to you. Right, then we need to connect 5 volts to pins 1 and 2. Pin 3 is ground. Pin 4 is 3.3 volts, which is this. This rail. Pins 5 and 6 are 31 and 32, so pin 5 is SDA, 5 is connected to pin 31. I don't know how I became muted. How long was I muted? Not sure when that happened. Thanks for pointing that out. A minute or so. Okay. Yeah, I was just ranting about how these connections don't make any sense to me. Like how this pin got connected to this when I specifically wanted to avoid it. But yeah, whatever. We got it fixed. So that should be the entire schematic now. So let's get it over to the PCB. And now we need to lay it all out. Uh, Wait, can I set this to only have one copper layer? Okay, I'm confused right now. Let me quickly look it up. Defaults to 2 copper levels. Yeah. Hmm. Okay, never mind. Seems to be a hard problem. Will not let me look it up. Too late. If you commented something in my still pint message, I missed it. No, I was actually just reading it. Wait. Very faint metallic taste. I don't appreciate metallic taste in my beer, because yeah, that's usually a sign of the bar not maintaining their taps and pipes. But still, I wouldn't expect steel to leave any. Then again, okay, I guess it depends on the type of steel. I'm gonna need to adjust the footprint on this. I don't know if it's a beer that somehow reacts with the metal. Thinking of how coins have a smell. Which have this old stainless steel cup. Not a speck of oxidation. Not reacting with anything for sure. Well, it doesn't necessarily have to be oxidation for it to be a reaction, right? Um, can I? Okay, yeah, I can reduce the. Yeah, I'm gonna. I'm going to stretch the pins of the transistor. I mean that it's not the cup rusting away and leaving particles of metal in the drink. Yeah, yeah. Order of operations. Wait, what do you mean? Screwdrivers are in the cellar because when I was working on the car, I just put all the work in progress, including tools, into a big box and put it in the. Oh, right. Okay, so now we have that lining up with the perf board. Cool. Now there's a few boxes of Kallax between me and the cellar. Uh-oh. And everybody's gravity. Yeah, easy. Easy clap. Gravity, who cares about that, right? Um, Gravity schmavity. You're alive. Yes, that's a good start. Off to dig through the cellar. 8 lives left. Yeah, I'm gonna leave myself some room. Wait, so can I... How does routing work? Okay. Uh... My brain just figured something out. Bread makes sandwiches. I'm sure we know what a breadboard is. So if you assemble daughter boards for breadboards, you're making a smorgasbord. Okay. Nice. Let's reduce the grade. So this will have to be a wire on the top, I guess. Differential pairs, nice. I wonder how you add wire links or jumper wires. Making a jumper wire, okay. Studios, they're appropriately sized, okay. Oh, this is beautiful. This is a ripper. Look at all those jumpers. That's how circuit boards used to be made back in the day. Ah. So, wait. Because wire at the top. It doesn't even zoom in. Could be some antenna of some sort, not sure. Oh boy, okay. I am not able to follow what people are saying here. I'm gonna do a dangerous thing. Watch a YouTube. Oh shit, okay. Yeah, I'm not logged in the browser. Okay, so this person is creating a new item in their component library. Eh, that's a hassle. And it has specific spacing. Okay, yeah, no. Oh, okay, so this is also just a bunch of jumper wire footprints created. Just realized what this post was about. Hmm. Oh yeah, that is a video. Okay. That's way more hassle than what I wanted to want to deal with. Okay, what I'm gonna do here is add a via here and a via here. And then route them on the front layer. I will use a jumper for that, but that's fine. So I can use the front layer for jumpers. That should do the trick. Okay, so do we have everything connected here? Or are we still missing something? Okay, we're still missing this. So let's route that. Oh, wait, what? What's happening here? Why is it doing these things? Actually, okay, let's not put a via there. Let's put a via below. I'm confused. Why can I not connect this to that? What do you mean? Why is it trying to draw that on a different layer? What the fuck? Huh? What is going on? They unlocked the memory from when we designed PCBs at school, the puzzle to have the lines connect where they should. Okay, this is all copper layers. Okay. And this is... Okay. Actually, okay. What if we don't make it a via, but... place... Okay. Kerbotly, habotting. Yeah. Mounting hole, no. No, but I do want to add it as a via so that I can route it on the top layer. Why is it not connecting there? When I think about spot has a lot of meanings to it. It's like, fuck. Wait, does it really? Okay, it has a few that I can think of. Okay. Connecting the trace over. Oh, you can change the net that is attached to. Okay, okay, right. Okay, so I can. Uh, so wait, how do I set up nets? Oh, there we go. Net. So that's a plus 12. There we go. Now we're getting somewhere. That's the ground. Cool. This is the 5-volt rail. Here we have yeah. Why can that not contain spaces? Okay, whatever. This is pan PWM. This is oh, okay. I have the pin assignment on J3. Why does it not match the schematic? That's so stupid. Okay, I'll have to rework that. This so pin 36 is 3.3 volt rail. And this is This is the 12-volt fan feedback. Okay. That's the ADC. So pin 20 or 31 is SDA. And this is I square C SCL. Let's go. So why is the order of pins like the So here they're why? This is 1, 2, 3, 4, 5, 6, and this is going along the long edge. That's so stupid. Why? Why is that the case? That makes no sense. I think this might be a similar issue to what I'm having. Though I'm not sure. Okay, I don't understand that. Everyone is used. Okay, odd even. Hmm. Oh wait, I might have connector. Oh, okay. 1, 2, 3, 4, 5, 6. That's okay. This is what I want. Wait, why didn't that do anything? Odd even change. Okay, there we go. So we have one. Let me actually check. 1, 2, 3, 4. Okay. Yeah, that. There we go. Wait, did my changes to the nets not get saved? What? Oh, come on. Why is it jumping around like crazy? All right. So again, this is the 12 volt net. What the fuck? Huh? Oh. Oh, really? Okay, that's so stupid. I needed to save for it to actually apply. That's 5 volt. This is 3.3. Oh, these two are crossing each other. That's not great. Wait, are they supposed to be crossing each other? Yeah, they are. Okay. Oh well. So yeah, that's fan feedback. Gotten spoiled? What? How? Why? What's going on? So that's the PWM. Save. Then we have the A square C, and this is that's the duty cycle potentiometer. Okay. So now this is the 12 volt net. Okay. Let's add another via here. Set it to 12 volt. And route it here. And then connect those. Cool. 3 years ago, I wasn't aware of the existence of ratcheting screwdrivers, wrenches. Now I accidentally grabbed my old screwdriver and got still very angry when I didn't do the ratchet thing. Actually, I do have a ratchet screwdriver. I don't use it that often. So for small screws and like electronics work, I use the iFixit driver. Doesn't have a ratchet. And when I drive self-tappers into wood and do that kind of work, I actually like to have a sturdy, just simple driver that doesn't have the ratchet. And yeah, might also be because the ratchet that I have is not that good, but I also don't care enough to get an actually good one. So Okay. We need to... Oh, there's going to be a lot of jumpers. I wonder if I should jump the ground instead. Because this is... Oh, look, it's trying to... Oh, this is cute. I can show you later what my issue with my ratchet is. Yeah, I feel like I should probably make a jumper for the ground rail. Can you not add a layer to go on the other side of the board? I mean that's the jumpers that I'm gonna be using. Screwed in 2 screws and I think you're down here. Ha. Yeah. So these red tracks, that's just like it's technically on the front copper layer, and I use that to indicate jumpers. But yeah, I think replacing this track with a jumper will allow me to route this directly, the 3.3 volt directly, some other things, so I should probably do that. So let's add a via there. And one here. Oh, whoops. There. Okay, I need to set, no, ground. What am I doing? There we have a jumper. This might also need a jumper. Okay, but we can route, oh whoops, on the back directly. Cool. Oh, this is probably also gonna need a jumper. Now a pile of Kallax between bed and bathroom, this is fine. Jumper is a connection that goes beyond the surface of the board. Yes. Yeah, that's what I do mean. Oh, we need ground there as well. Okay. Those can be shorted. Um, or, oh, you meant add a layer to go on the other side of the board. Um, well, I mean, the way you make connections on these perf boards is you just kind of bend the leads of your components to go across multiple holes. So you don't want those to cross. I do actually need separate wire jumpers for that. You don't just add solder to connect the dots. I mean, that's one way. Yeah, you can just use solder blobs, but I feel like that's unnecessary use of solder. But even then, like the holes are going through, so I couldn't cross. Like if I have a connection going on the back here, for example, I couldn't just make a solder blob on the top layer because it would connect here. It would short out. Okay. I'm gonna add a jumper for 5 volt here. Wait, what is this net? Right, that's the fan feedback. Right. All right. I want this sort of out of the way. I'm going to need to jump the 3.3 volt to this. There. And then jump this 5 volt. Oh. But that's getting, okay, it is getting a bit messy, but because I will have crossing jumpers there. Yeah, I might not be able to represent this on the uh, layout, but that's fine. We will jump that. So that's the fan feedback. Yeah, the high voltage signal. Oh yeah, that doesn't let me move that. Okay, whatever. So we are missing this. Oh wait, that is routable on the back, but I don't want to do that because then I will block. Yeah, I'm gonna need to run jumpers to these pins. So it's gonna be so many parallel jumpers here. Now in practice, I will route the cable, the wire straight, but that's fine. Yes, and again. It's gonna be a straight connection, but whatever. So what are we missing? Oh, okay, so this net is SDA. This is I square CSCL. And then we have the 5 volt. That we need to jump over here. Why did it do the squiggly thing here? Yeah, that's fine. Again, that's gonna take a more direct route, but that's whatever. What are we missing here? So this is, oh yeah, that's that can go. Oh, that cannot go. Yeah, it needs to be jumped. And here, actually, okay, I want to first do that, then that. Ah, shit. This is ADC. What's going on here? Okay, let's just delete that. Start over. So, yes. All right. So got that, and there's only two more missing connections, missing links. So that's the SCL and SDA for the display. What a fucking rat's nest this is gonna be. But fun. Okay. I'm just gonna run jumpers. Wait, what? So, and then I can actually not what I wanted to grab. That's what I wanted. There we have it. The work is done. Now I don't need to see all the labels. Which ones are those? Oh, it's the fab layer. We don't need that. Or all right, whatever. Let's get soldering, shall we? This took a bit, but we got there. Ah, and now we finally put it all together. Yes, skibbity dop dop dop, yes, yes. Let me get all the components in place. So that's 4-pin gap there, 3-pin gap on the other side. Maybe okay, I will do that one later. Yes, hydrate, stretch and posture check. Thank you, thank you. Yeah, much needed. Oh. Appreciate it. I should also try to find, okay, yeah, I have the headers here. What else do we have? Need to eat something and I really don't feel like it. You can do it. I believe in you. You got this. Okay, so yeah, here's our headers. So this is the 3-pin part of the 4-pin fan header, because this needs to fit the somewhat unusual PC fan header, which has kind of the 4th pin just added in, but it expects the guard for a 3-pin header. Yes, so this is going to be our 12-volt supply coming in. And we want it mounted with this orientation because oh, whoops. Yes, ground is going to be on this side, and 12-volt is how thick is this wire? This is very thin. This is 26 American wire gauge. Ooh, okay. I guess it doesn't matter. This is not going to draw that much power. But yes. So we are going to start off. It's really thin. Yes. But I think these jumper wires are also 26 or even 28 gauge. They're extremely yeah, because this is one of those soldered to a 24 gauge wire, I think. Anyway, stupid fucking American wire gauge. Whoever came up with that shit, why can we not use millimeters and millimeters square? This is my homemade flux, of course. It works really well. Just gonna gently dip. Actually, that's a less bad idea than other US units, at least it's proportional to the resistance. I mean, yeah, still have my reservations about it, but I'm willing to grudgingly accept that one. So let's okay, I think I used a little bit too much solder there, but it's looking a little bit better. Millimeter square would be 2, yes. Let me just wick off some of the excess solder. Okay, that's looking better. It's a little bit crooked, but whatever. Manual work doesn't have to be perfect. So then we need a 330 going here. Probably shouldn't have started with the tallest component. Wait, the 330, yeah, and I need to bend the lead over in this direction. And make those connections. I probably was too eager to wick that excess solder away because kind of need it now, but that's fine. Let me just use another component to bend this lead. Trim the excess. Oh, whoops. that pinged off into the abyss. Yeah, I'm gonna need to clean up after. I don't want the thing to keep tipping over, so let's get the helping hands in. This song was, ooh. Also, Circle of Dust is a pretty good band. Also discovered through Pretzel. Need a little bit of flux. That's looking nice. Okay. Next, I want to salvage this 5-volt regulator from my earlier prototype. But I first want to test that it actually works. And we're going to salvage some wires for the jumpers as well. I wonder, will this fit the breadboard? Not really. Oh, wow, okay. I need to wick that off because those pads be thick. Come on. Maybe after I wick them off, they will fit the breadboard too. No, did I just solder my solder wick too? That's better. All it needed was just a little bit of flux. Might want to give the same treatment to the backside, but I want to let it cool off a little bit. Now, just keep it going. There we go. Nice and clean, as good as new. Except for the flux, but we can wash the flux off with a little bit of isopropyl alcohol. Also, I gotta say, these, was it 5 milliliter tiny plastic squirt bottles with thin nozzles were a fantastic investment. AliExpress delivered. And it fits the breadboard. Let's go. So let me just quickly get it hooked up to a 12-volt power source, and let's check that it works. How do you manage to remember how to do electronics anyway? How often do you do it? Not very often, but I mean, so look, I spent my teenage years with a soldering iron in hand. At one point, I actually loaned a book from the library that I used to go to, which went into great detail on how Z80 processors worked and how you could go about designing an entire 8-bit computer with Z80. Nerd? Yes, absolutely. I grew up with the smell of flux in my nostrils. Let me just get some wires here to probe with my meter. I have it. Yeah, I have the. Also, I got some new probes for my multimeter. These sharp needle probes, really handy. And also an attachment with hooks, which is also quite neat. I want to get better hooks. These are just kind of cheap ones that I found, but already quite useful. Okay, let me try to find the adapter that I used for this. Where did I place that one? What's wrong with me? What did I do with it? Why am I like this? Disco Elysium. I hear that's a good game. And I have it in my library now, so I will play it at some point. The fuck did I do with the powers brick? I was just trying to remember speed skating stuff again, and turns out I forgot everything since last year, so I was wondering about the half-life of other people's hobbies. I mean, so there's the, you know, the childhood part, but there's also the fact that there's plenty of electronics tinkering content available on the interwebs, and every now and then I just watch a big live video because I find it very relaxing to watch other nerds reverse engineer all kinds of weird electronic gadgets. And that also helps keep the knowledge kind of fresh. I've also seen a bunch of Louis Rossmann MacBook repair videos, which is another reason why I will never ever buy a MacBook. Because holy shit, those are so poorly built. What did I do with the power adapter? What the fuck? I cannot find it. I guess that'll help, yeah. Tablet pen. Oops. Seriously though, what happened to this thing? I kind of need it. I mean, so I can... Oh, found it. Woo! Okay, I need to declutter this space a bit. But okay, we're safe. Okay, let's set the multimeter to the 20 volt range. Connect this. And we're getting nothing. Why are we getting nothing? That's not good. Uh-oh. So are we not getting anything because the power brick is dead, or because... Okay, we're not getting the 12 volts. Why are we not getting 12 volts? Okay, let's try without the linear regulator in place, and we are getting 12 volts. Okay, that's good. That's a good start. But then the question is, do we lose 12 volts as soon as we plug the regulator in? No, we still have 12 volts. And we get 5 volts on the other. I wonder what happened. But yeah, okay, so the voltage regulator seems to work fine. All right. Must have been a glitch in the matrix. Okay. Moving on. So we can use this regulator. It seems to be doing its job. So it goes here. So the ground pin I want to bend and get over here, because this is our ground plane. I probably want to shorten it by just a small fraction of, or maybe a millimeter. The other leads, I'm not sure if I will be able to bend them. Maybe I will. Yeah, that works. That works. They have this sort of rectangular shape, so that'll do. That'll do. I'm gonna need to figure out a way to emulsify isopropyl alcohol with glycerol. Come on, reflow. Cool. Hey, fat corn. Isopropyl glycerol. Tablet pen found. Nice. Well done. Prefer ethanol and tonic. I mean, cheers. I'm not a fan of hard liquors and that kind of stuff, but yeah, I'll skull with water kefir. Mm. I'm gonna need to use a little bit of copper wire here to make that connection. Then again, no, let's continue with the next component, which would be the 5-volt side capacitor. So that goes in here. Yeah, and we can reach all the way here with that lead. So no need for a separate wire just yet. And the other lead, okay, bend the regulator. I'm gonna clip this. Okay, got that merged in. I think we might need a little bit more solder there. To make it a big fat solder blob. Make sure to reflow that together. And then that. And there we go. Give it a few seconds to cool off. Now, I wonder, would I be able to get the lead of the 5-volt regulator to reach all the way to the capacitor here? Yes, that will do. Still quite hot, so I'm gonna give it a few seconds to cool off. Tiny little dab of flux. There we go. That seems to have a nice solid joint. And I want to clean this up just a smidge. All right. Next. So we have this part in place. Now from this capacitor, we need to bend the lead this way and reach over one hole. Let's clip that off. I can actually save the bits of leads to use as connecting wires. Now this is going to be a jumper from let me just see if this will be sufficiently long. It might be, actually. From here to... So that's... 1, 2, 3, 4, 5. I wonder if it's possible to just highlight a specific net. Hello? Oh, it is. Okay. It's a little bit clunky, but that's fine. So we need that jumper over 1, 2, 3, 4, 5. Yeah, this is even too long. Okay. And I'm not gonna install the jumper just yet. Just wanted to know if this will do, and it will. Being reminded about... Oh, right, about a painting day tomorrow. Thanks, calendar. So anyway. What next? Like this could use a touch more solder over here. Yeah, it was a little bit anemic. So if we continue with the 12-volt net, we got the resistor, which goes here and takes up one, or has a gap of 1, 2, 3, 4, 5 holes in between. That seems to fit perfectly here. Then underneath the resistor, we will have this fan header, which goes here, and then one more pin next to it. Let me just see if I can find the matching pin. I know I have those, so there we go. I need a better way to organize my components. That's why it's called a breadboard. Wait, what? Why? So let me break off a singular pin here. In the early days of radio, amateurs nailed bare copper wires or terminal strips to a wooden board, often literally a bread cutting board, and soldered electronic components to them. Oh, nice. But the butters to a wooden butt. Butt really called a cutting butt. Butt's what's weirdly consistent there. Nice. So that goes here. It's not quite the same length, but hopefully it will still make a connection. I will need to have everything plugged in while soldering this, though. Oh yeah, okay. It will make a connection. It's gonna be fine. But yeah, that will go there in a little bit. If that's the wooden butts thing. Wink wonk. Because of the resistor, needs to be routed. Then 1, 2, 3. Okay, so 1, 2, 3, and here it takes a turn. Okay. Whew. Wait, I have it on the in the wrong position. No, okay, I'm kind of messed up there. Or did I? Wait. Oh no, oh no. Okay, I have it going the wrong way. So it needs to go this way. One, two, three. And then down. Okay. Boop. Hey Dar, Boop. How you doing? Welcome, welcome. This is what we want. And that's pin 2 of the header. Hey, Philo or Philo, welcome in. I noticed you followed while I was offline. Thank you for that. Welcome in. Um, met me. Right. Yes, yeah, that's right. How you doing? Welcome in, welcome in. Hope you're having a wonderful day, or night, or whatever your time zone is at the moment. The stir is going to be so cool. Yes, it is. I was itching to make some more progress on this. Yeah, Dar, just to give you an idea, I was doing the component layout on the breadboard earlier and routing all the connections. So yeah, we have a schematic here as well. So we're assuming we wanted to make sure to say hi. Oh, nice. Yeah, all good, all good. Enjoy the games. Hope you have fun watching them. Thank you. Likewise. Same to you. So we got the resistor one, right. One of the leads. I can get it in place on this end. We are supposed to have, yes, one whole gap from the cap. All right. I'm just looking at the solder joint here on the cap, and it looks like the solder hasn't. Oh no, okay, it has flown all the way. It just there's slight layer of flux. That's fine. It's not an issue. But the ground lead of the voltage regulator, I think I need to reflow that. It didn't fully flow through the, well, it's kind of difficult because the regulator has it sinks a lot of heat, especially the ground pin. So it's kind of difficult to get the solder joints up to temperature. Okay, is it looking any better? Not by a lot. I guess I'll just have to take it. Okay, so what next? Next we have the, okay, this is kind of loud. So it's really blasting my ears. I actually opened an issue report with Pretzel about the inconsistent volumes, and we're like, I mean, other people in their Discord were, yeah, I also get my ears blasted off by Pretzel. We're like, we already do normalize things. Okay, apparently you're not doing it well enough. Okay, so for the other lead of the resistor, I need to bend it parallel to the one we already have in place. And this is going to be a little bit tricky. I definitely don't want them to short out, because that would be bringing 12 volts to straight to the Raspberry Pi, which we definitely don't want. But yeah, this should do. Let me clip these. The resistor has very chunky leads, so I'm not sure I will reuse those, but kind of difficult to manipulate. That wouldn't be good. No, not at all. But yeah, so we have that routed. Let's solder it into place. Come on. There we go. Now it has flown nicely. That's some really nice solder joints on this resistor. So what next? Next we gotta get the transistor setup. That's going over here. Let me just double check the pinout, but I believe that all TO92 package transistors should have the same pinout, or most. Let me just pull up the data sheet. This here is VN10K. Yes. N-channel MOSFET. Gate in the middle. Source is connected to 12 volt. Yes. Or yeah, on the high voltage side, connected to 12 volt through the resistor. Oh, actually, no. If I shorted it out, it wouldn't directly get 12 volt to the Raspberry Pi, but it still wouldn't be good. And then drain is on the low voltage side, going directly to the Pi. Yes. All right. So the pinout matches. Now we are going to need some jumpers. Let me get one lead in place. That went super fast. Tiny little component, doesn't sink a lot of heat. We actually need to get all three leads in this direction. But we need to clip the source and drain after two, or on the second hole, yes. Looking beautiful. It's a little toasty, but should be fine. So we're also going to need a 3-pin header. So let's get that. And that header is gonna be sitting Is it the same? Yeah, it's in line with the resistor, so it's going to be sitting right there. The fuck is this song? So I grip the header in the helping hand to have that as a fixed point. Oh, this is going to be finicky. It doesn't extend too far through the circuit board. All right, that'll do. Oh, okay, we need to reflow that, but there we go. That's good enough. And this, because that's the 3.3 volt rail, and that extends all the way to the Raspberry Pi header. The Raspberry Pi is what's generating that one. Wait, is this MOSFET directly connected to 12 volt? No. What's this rail? All right, that's the low voltage feedback. Okay. So that's also going to take a jumper. Yeah, for now we have that in place. That's good. Okay, what next? What are we actually missing? We are missing the Raspberry Pi. We are missing the fan header. So the Raspberry Pi is gonna be sitting here. Then I'm gonna need a bunch of wait, okay, do I want those to stick out, or do I want to have receptacles? So for the display header, I can either use these, doesn't really matter. I have more of these, so I'll just use them. In 2 rows. Those are going here. Up, up, up. And here. It would be preferable to keep them aligned. I'm not sure how realistic that is. But, oh well, I mean, hot melt glue will solve everything anyway. This is gonna hurt. Hey D3, how you doing? Yes, ow, 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 this hurts. They're not aligned at all. Well, that's good to hear. Yeah, I'm pretty good, pretty good. A little stressed because I'm gonna be painting my living room tomorrow. But I'm looking forward to the result. I need this to cool off a bit because it's really... Should go to bed. I'm grumpy at life, the universe, and everything. Aww. Good luck with that. Thank you, thank you. I have booked a Steam wallpaper remover for the weekend, so hopefully that goes well. But yes, if you're feeling grumpy at the universe and everything, getting some rest might be a reasonable way to ungrump yourself. Really need to finish my car's speakers one of these years. Look, it will be ready when it's ready. I would advise not stressing about it too much. We need some flux here. What do you think about all the DIY things? You want, I mean, yeah, that's fair, but also to keep things in perspective, the world doesn't end if music takes a few more weeks or months. To manifest. Grumpy because specific things resting won't do harm but won't solve things either. Yeah. I get that. I can offer a virtual hug. It won't solve any of the issues either, but it can at least sometimes help with the grumpy bit. At this point, I think music would be more helpful than distracting. That's fair. All right, I think it cooled down enough. So let's get the middle leads soldered in. There we go. It's always a bit finicky with these plastic terminals because they are very prone to melting. So the window between getting a good solder joint and them starting to melt is very narrow. But we're good, we're good. They're not perfectly aligned, but they don't need to be. I will be DIYing the counterpart anyway. With some hot melt. Have fun with finishing stuff. Thank you, thank you. I'll try. I will DIY something similar to this. So just hot melt 2 rows together and well, I mean, first solder wires to them and then hot melt together. While it's plugged into this, so it's aligned as it's supposed to be. All right. What else are we missing? We're missing the fan header, and then all the jumpers. Maybe it's time to start dealing with the jumpers. I'm gonna try to salvage some of these wires that I have here. from the previous prototype. Some of them have a little bit too much solder on the leads. This is a terrible idea. I'm gonna burn my fingers. Do you have any jumpers on the ground plane? Let's see. Yes, we do. So that's from the resistor 1, 2, and then 1, 2. And this is where the ground of the fan header is gonna be. Wait, does that match? No. That does not line up with my schematic. Okay, where did I miscalculate? So we have the capacitor, then skip 3 holes, and then fan header ground. So capacitor, skip 3 holes, and fan header ground. Wait, did I have it correct? I don't actually know. Okay, so it's supposed to be on the inside of, yeah, on the inside of that bend. So on the inside of this bend. So it's right next to that. Yeah, okay, I did misplace that. That's it. And that should reach the ground pin just fine. So let's get this soldered in place. There we go. That was nice and fast. And then that will go over here and 1 pin past the transistor. Or actually, it can even go all the way to. So the only thing we're connecting here. Oh no, okay. Yeah, we do want. Okay, we're connecting several things. We're connecting this pin here, this, and this is going to be the ground of the Raspberry Pi. So we want to use this through hole. It's gonna, okay, we're gonna need to splice some wires in there, but that's fine. Okay, let me crop this. And strip the sheath. I have it way too long. I wasn't sure how. Well, I would do stripping. Okay. Hopefully I don't mess this up. Or worst case, we'll get another bit of wire. Guess I was too gentle. There we go. Just quickly thin the one wire. Dip it in a little bit of flux. Flux always makes things easier. And then through the hole, into the wormhole. Need to help myself with the tweezers. There we go. Wires through the hole. Just want to pick up a little bit of solder on the tip. And flow it on there. Cool. So we got our first jumper in place. Now it's like a dozen more. Just manipulate it on its line. All right. We are gonna need to jump that over to, well, okay. This might actually be a fairly suitable bit of wire. One of the resistor trimmings. Before I do that, let me just double check that I didn't make any mistake with the display header. It would be really embarrassing if I realized now that I have the display header flipped. So let's make sure that we have it correctly. So I believe the way I set it up was, yeah. So we have ground 5 volt, 5 volt, 3.3, and the data pins. So ground 5.5, ground 5.5, .3, and the data pins. Okay, it tracks. So, whew. Better safe than sorry, though. I feel like I might have melted the sheath of the jumper wire a little bit. Ah, that's fine. It'll survive. That seems to have flowed together nicely. Yes. Yeah, these wires have a very, very low heat resistance on the insulation. I got a better wire later, but still want to use up this first. So next, should I put the tie in place? Guess maybe I should. It's going right there. Kind of just need to get one pin fixed. Okay. Let me see. Which one would be a good start? I guess the 5 volt rail might be a good start. So that's gonna be this second pin from, or well, 39th. Just have it fixed in place, and then it won't wobble around. Need to shake the flux container a little bit. Get it emulsified again. The helping hands are not doing anything for me here. Just double check that I have it lined up correctly. Yeah, seems to be the case. Come on, flow, you bitch. Okay, I feel like the solder joint is not quite the quality that I would like. Let's dab a little bit more flux on there. I mean, these pin headers are not meant to be soldered, I don't think. It still looks like a cold joint. On one side of the pin. So maybe a little bit more flux. So one side looks good, but the other one very much not so. Okay, that's better. It's not perfectly aligned, but it is what it is. This row of pins is going to be getting in the way. Might have to. I'll just clip them, and I mean everything on this side as well, because I will want to mount this with some M2 screws. There are some screw holes here for M2 or 2.5. So it's going to be screwed into its box. You're getting screwed, you hear me? Yes. So then for the 5-volt rail, we have another jumper, which is going from right at the output of the regulator, so where the capacitor smooths it out, and we already have the lead pre-bent, and it's going to here, because this pin is the 5-volt supply for the Pi. I will want to shorten this to right about where the sheath currently ends. See if I can nibble away at this sheath without breaking the wires. It's resisting sheath really didn't want to be cut, but we got it anyway. Twist the wire a little bit so it fits through the hole. Will you fit? Yes, you will. All right, pre-tin. That worked surprisingly well. So let it cool down a bit. And get it into its holes. Oh, they say this new Elysium, not Disco Elysium. But I'm wondering, okay, maybe I should wait with this one because this will go over a whole bunch of other jumpers in the same row. This row of holes needs to take a lot of different jumpers. So let's salvage some more wires from this previous experiment. So what other jumpers do we need? We have fan feedback 3.3. is going from a pin right next to the 5-volt output to, oh, I've already covered that. Okay, kind of silly of me. So it goes from here. Is that not fitting in? Oh, it does. It does fit. And it goes to the drain of the MOSFET, I believe. So let's crop this about here. I'm gonna give myself a little bit of headroom to route the jumper and also have a little bit of the wire sticking out on the other side. All right, we got that pinned. So need to kind of finagle it into place. I want to bend this over to the GPIO pin here. Okay, I guess I gave myself a little bit too much headroom. I might need to shorten this some more. It's also a big solder blob at the end. Right, let's try again. Okay, that's a little better. Come on. Oh. was blocked by the MOSFET lead. Okay, that's not looking too terrible. Oh, I actually wanted to, yeah, I wanted to have that one in a different row. I wanted to have one there. It's a little bit longer than it needs to be, but we can live with that. It's gonna be another jumper from the adjacent. Just gotta bend the MOSFET lead out of the way to keep the hole open. So we've already bridged that. Yes. Is that a that is, I believe, the 3.3 rail, isn't it? Yes, it is. So there we'll have a jumper over to the display for its 3.3 supply. Holy mother of solder blob. What happened here? It's all burnt. Yeah, no, okay. That is getting trimmed. That's too nasty. So here we need the 3.3 rail jumped over to the 3.3 supply. Pretzel, why are you so loud? Whoops. So this is going to be a fairly short one. But I do want to give myself a little bit of extra on the other side to bend. That was clean. So that is getting jumped over there, but we also need a jumper from here, which is right next to that one. We have a row of 3 jumpers there. Oh, and that is getting jumped over to here, so just below the resistor. Because that is... Oh yeah, so the resistor is pulling up the 12, the high voltage feedback signal. So that is a 12 volt signal line. Let me see. Again, I'm gonna strip a fairly sizable chunk of the wire. So we'll need to attach it on the other side. Okay, this is way too long. Right. Oh yeah, I haven't cut it to size yet. So we need to reach the middle pin of this header, or not exactly, like we're not connecting to the middle pin, but we need to reach the source of the MOSFET. It's going to be a little bit tricky to get all into place. So we have 3 jumpers that are kind of getting up in each other's faces. So goes into that hole and that hole. And here it's blocked by the, okay, by the MOSFET lead. We'll get that out of the way. Right, that's good enough. And then we have this jumper for the 3.3 rail. And that's going in here. Technically, they're not crossing each other. But they're really, really cramped in there. That's fine. So now they won't even fall out because they're kind of keeping each other in place. So that's nice. Now, what else are we missing? So the 3.3 volt rail is, it's also missing the bridge over to, well, where it's generated, the pi. To the outside here to minimize the risk of any accidental shorts. That'll do. Accidental shorts or other pants. All right, so the 3.3 volt rail is finished. Now, are we missing something on the 12 volt? Yes, we are. We are missing a jumper from the input of the voltage regulator to the resistor. So let's get that in place. Or is that what? No, that's not this. This jumper is for 5 volts. Yeah, that's yeah, to power the board. Have that one pre-cut, ready to just slide in. Now pretzel is very quiet. There. So one side is going over here. And the other side is going there. And is supplying power to the resistor. Okay, it doesn't need to be very long. So we will need to fold it over on both ends. All right. Needs flux. There we go, much better. I actually feel like I want to route that underneath this feedback jumper. There's also going to be a PWM jumper going from here all the way to the fan header. Wait, have I? Oh, I've bent this already. Let's get this out real quick. And get this 12-volt jumper in place. Oh, does it not fit? Put on too much solder. Could be better. Like a glove. All right, now let's get this end in its hole. There we go. Beautiful. So this needs to bend over to the resistor. And this needs to bend over to the 12-volt rail. Cool. Ay, ay, ay. Drop the thing. What's up? Hi. Let me double check. Where does this go? So I use white wires for signal lines. But I dropped something else out. Ah, shit. Right, this one goes... Yeah. There and... there. This one bridges the resistor with the source of the MOSFET. And stay in there. Okay. So how many jumpers are we missing? We have the long 5-volt jumper. Still missing a whole bunch. So from this adjacent pin here, we need another data jumper going to the fan header. I wonder if I should have put the fan header in already. Yeah, so this goes over to there. And that is underneath the ground jumper. And since this one is shorter, I probably want to keep that under, or underneath the long one. Ooh, the algorithm. Let's go. I knew I recognized this tune right away. I'm not gonna skimp on the flux, I have plenty. My stream preview died in both computers. I wonder why. OBS is not telling me anything is wrong. That's really awkward. Get in the hole. It fits. Let's go. But then we have, oh boy. The fan header complete. Yeah, I should probably first install the fan header and then all the jumpers, because otherwise they will be blocking the... Yeah, they're kind of getting in the way. Especially that one. Okay. Although this one is not great either. Okay. I didn't get enough clearance. Well, we'll make it work. It's getting a little bit tricky to get the solder flowed onto everything that it needs to be flowed to. Okay, and then the ground pin. Nice. That worked out. There we have the improvised 4-pin fan header. I don't know why it's so difficult to obtain the correct header. Like, you could have ordered one from AliExpress, but it's just not available locally. Right. Now we have that aligned. I do kind of want to clean up the solder joint on the 12-volt pin. There's a lot of chunky leads here that sink a lot of heat. Okay, I think that'll do. Yeah, I didn't want to just use a generic unkeyed header for the fan, because oh, okay. I had a small scare because I noticed that I want to run a jumper from here, which is right next to the hole on the header, but that is the one that's not part of the header. I was a bit worried at first, like that, because looking at the header, it covers entirely the next row of holes, but this one is not covered because that's not the header. So we're good. We're good. And that is this jumper right there. I might route it over the long one, because shimming it underneath is a lot of hassle. So get in there and in there. This needs to bend over there. And these go straight to the pie. Whew, I'm getting hungry. Also thirsty, and I need a bathroom break. So I can try to put on words, even though there's not much activity. We'll see if anyone bites, and if not, I'll be back in a couple of minutes. Good try. All right. I'm just gonna go back to this. Not really? That's fine. No worries. Wait, did you pop in earlier, or was this the first time you chimed in today? My memory is. Because if this is the first time, then hello there. And if not, then disregard me. First time just looking. All right, all right. Do you think? It was a really bad day? Oh, I'm sorry to hear. How's me? I mean, I'm really enjoying tinkering with this little thing. It's been a long time coming, so that feels good. My day was kind of slow and hungover. A little bit stressed about the painting tomorrow, but it's not too bad. So yeah, I don't know. Kind of just existing. Okay, what else do we need? A whole bunch of other jumpers in this row over on this side. So we have a jumper. One going from all the way here to here. It's going to be among the last to put in. Then we have one going from here to here. The one is kind of just wrapped by the other one. We have one from here to the middle pin of this header. Yeah, so that's the ADC. This tiny little piece of wire should do for that one. That is the shortest one in here. So let's get that in place. But yeah, do you want to talk about what's going wrong? No need to, if you don't feel like it. Just if, in case you feel like unloading, you are welcome to. Just woke up without spoons. Yeah, happens sometimes. Sorry to hear. Let's apply some flux. It's almost early work. This wire is so short, it gets hot across the entire length immediately. Nothing specific this week. Gotcha. I'm a bit stressed because I genuinely have no idea. Hey, Brooklyn. I have absolutely zero clue about what colors I want to paint the walls in my apartment. Like, and I don't know how to deal with that. Yeah, we just need to jump 2 holes here. So from here, can we go wrong with white? Blue, because blue is the best. Maybe some like very light blue. I don't want any dark colors for the living room. I was thinking maybe, well, maybe something like beige. Do you recommend blue? Wait, really? Okay. Blue is hard to paint. Fair. That is a fair point against blue. So on this side, doesn't go on evenly very well. Yeah, I wouldn't want any dark colors anyway. So on this side, it goes to the header, and on this side to the microcontroller. That's a very clean jumper. If I can get it soldered in without messing it up somehow, but I don't see how I would. Well, how are you doing today, Brooklyn? How's life treating you? Oh, and this is the ground plane. Okay. So that connects, yeah, through this jumper that we already have in place, and just straight across. So something like bah. Okay, this is a little bit too long, but it's fine. Wait, is it really ground? Guess it must be. Yes, it is. So pin 38 is ground. But we also need 2 more jumpers. So we need one from here to here. Let's get on that. I do have a fairly exciting thing though. Today I ordered a wireless in-ear monitoring thing so that I can walk around the kitchen during my cooking streams with wireless, wirelessly connected headphones. So that's pretty neat. Looking forward to that. I'm really curious how this will work because it's it's a monitoring system that is meant for artists performing on stage. And there's a lot of very conflicting reviews for it. A lot of people complain that there's a lot of noise. And then there's plenty of reviews according to which it's clear. So I'm guessing it depends a lot on the environment and the amount of radio noise in that frequency band. So we'll see how it works out in my apartment. That in there. We will still need to put in the jumper for 5 volt. I guess I might as well do it now. Because that's going over here. And I want one more run of white wire. This one is too short. Oh, whoops. This is pulling out. Clip this so I don't need to clean it up. Yeah, the insulation was kind of toasted on that end. So Right. So adjacent to the other white jumper. Oh, this might be the perfect length even. Should be going. Should have gone quite a while ago, but oh. I do hope you get some good rest. And fingers crossed for more spoons tomorrow. Oh shit, it's almost 2 in the morning. Okay. Yeah, I should also try to wrap it up soon. I got completely lost in this. Huh. Good night. Yes, thank you, thank you. I was hoping for more progress today, but honestly, I cannot complain too much. Still a decent chunk of progress happening on this, so... Hmm. All right, let's get that in there. Get through the hole. Yeah, it's a little cramped with all the jumpers. A little shady, but that's fine. There's one more for the 5-volt rail. And that's gonna go from here to here. Yeah, this piece of wire will do. But yeah, the time explains why I'm getting so hungry. Will do. Hey, Verangatrix, welcome, welcome. How's it going? Slow, but the project is making a lot of progress. I'm just putting in. I hope to be finished with the soldering and the electronic part of it by the time I go to bed today. And then all that's left to do is mount it into a box. Come on. How are you doing? Did you join the quiz? And if so, how did it go? I kind of drowned that in flux, but that's fine. You won the quiz? Nice, nice. Well done. Congratulations. Come on, melt. Here we go. Found the source of the issue with the cert. It was a code bug. It was actually working perfectly fine. I just had the math wrong that calculated RPM from the pulses. Proper group effort? Nice. Well done to both to all of you then. Who was there? I know, like, yeah, Kiddo texted me earlier in the day. But yeah, this week just didn't really fit my plans. I do hope to join another time though. Right, let's start soldering all those jumpers in. Yourself, Kirill, Natasha, and Anders. Nice. How big are the teams allowed to be? That's barely. Or as usual, right. Many of the cues were Swedish, but my favorite was a Geo one. What was the question? Shit, okay. This is, I lost the connection there. It's kind of finicky. What monument sits in Agra? Okay, I have no idea. See, my problem with quizzes is I just don't hold the quiz kind of trivia in my head. Okay, kind of drowned that in solder, but it seems to have gotten the job done, so yay. And while I'm at it, I might as well, because both of these are 5 volt. Fair enough, so it was a software issue then. Yeah, exactly. It was actually, yeah, just the wrong number being displayed. So let me try to bridge this with a piece of scrap. Actually, yeah. This is the helping hands again. Make it a little bit less finicky. Hopefully. This is going to be fairly tricky to get in place. Oh, come on. Fuck. Okay. Getting somewhere. Remember, because Bharat was adamant when we went in Delhi that we would not go to Agra to see the Taj Mahal due to cost and it being a tourist trap. Right. Nice. Yeah. Memories like that stick. Let's dip a little bit of flux on there. Should help flow everything together. Okay, let's see. Okay. It's a little messy, but it'll do. So if the issue was software, yeah, I'm just giving it a finalized form because this breadboard was a mess, and it wouldn't fit in the box. It's the small things. We ended 18 out of 21 questions, so quite pleased. Well done. Yeah, I needed to give it a more compact form so that I can, you know, this is the box that I use for it. So I want to, you know, have this circuitry sit underneath the fan housing, and yeah, otherwise it wouldn't fit. All right, what next? I should probably do the other side of this. Okay. So here we have the 5 volt, the other side of the 5 volt rail with 2 jumpers. This one bridges it over from the 5 volt source and brings it over to the microcontroller, and this then bridges it over to the display. So just really working around, yeah. Which finally the Polish train saga you sent, very right. Yes, it's like the blatant abuse of public resources is really infuriating. Okay. What is this song? I like it. I hope it's meant ironically, though. All right, so oh, no, I need to ground this. Love the geolocking on their own site. Hard to argue that point after that, amongst many others. Yeah. Geolocking of their own workshop that just so happens to be implemented but then disabled. Like, oh, yeah, pure coincidence. Okay, this is quite the solder snake. Okay, cleaned it up a little bit. Come on. I think that's about as good as it gets. I was asked the other day about beneficial geofencing. What do you say is a positive example? Huh. I don't know if I can answer that off the top of my head. Also, I'm not sure I really understand the premise of the question. Okay, what else do we have? Okay, this reaches all the way. Not sure if the other one will though. I don't know. Do you have an example? I'd argue all commercially available drones should be geofenced against active airports so that they shut down when entering civilian airspace near airports. Yeah, I guess that's fair. Yeah, because they could cause a lot of harm. That is, yeah, probably a pretty good example. I would agree. With the caveat that I haven't spent much time thinking about that matter, so. If you bypass that, you must have damn good reason. Yes, yeah. I'm generally not a big fan of drones overall, so. For recreational use. Or, well, not just recreational, to be fair. Ah, this almost reaches, but not quite. Yeah, this jumper is a little bit stretched. Out of curiosity, will this? Okay, yeah, it has enough room there. For photography, they're amazing, but not near other flying objects, particularly those that carry passengers. Yeah, yeah. Waterborne unmanned devices. Okay. Got the 3.3 volt rail. Although, not entirely happy with that joint. So I can. Yeah, that's better. The wire was really sticking out there. All right, then we have the other I2C. Do you have any interest in carbon-based life forms? Oh. Yeah, I remember looking at that show and interest, yes, but I don't know if I have the time and honestly the spoons for it. Because I have a lot going on right now. Yeah, I don't know. Let's get another little scrap. Wait, no, this is not the kind of scrap that I want to use. That's yeah, let's use this. Just need to bridge this fairly short gap. It's looking nice. And then pull that together. And we got a link. I'm not yet found another interested party, so we'll hold off. That won't go alone, it isn't cheap either. Okay. Ooh. Like, the price wouldn't be an issue for me. It's more. Do you remember when it's taking place? Off the top of your head? Okay, then we have this, and aren't we missing something? Oh yeah, this all needs to be bridged. The only confirmed gigs I've got on the table are Inferno and Blind Guardian. Thank you, thank you. '20th of March. Wait, isn't something else happening? Isn't Julius's birthday party somewhere around that time? Or am I mixing it up with something? Wow, brain. Thanks, brain. Okay, one step at a time. One step at a time. Oh, the algorithm, nice. I feel like I might be time to bring out the magnifying glass. No. Oh shit, okay. There we go. Party is 16th, 20th is Wednesday. Oh, okay, okay. March is gonna be long. Oh, I can suddenly see. Then bring it up to apply pressure. Yeah, no. No, I haven't. Right now, my planning. I struggle to plan anything beyond next week. Though, yeah, I still need to. I need to reach out to the hostel in Oslo. I need to do that sooner rather than later. Packed with shows, but what's on your mind off the top of your... Oh yeah, there's just a couple of other events, not shows. There's a moving out party, there's the birthday party. I don't remember which shows are happening in March either. Um, okay, I guess the next on the line. Oh, because I want to get to Oslo a day before the rest of you and see if they have a nice and convenient solution, or just book a book a bed and be done with it. It's on the other side there. Am I tripping? Oh, right. Yeah, no, that's a bit of the lead. Bridging the all right, that's the ground plane. Arriving one day earlier, just an email away. I guess it's the cheapest will be a shared bunk, but yeah. Yeah, no. I wouldn't hope for that. I just I don't. But yeah, a shared bunk is probably fine. This is too loose. Yeah, that's better. But I hope I didn't scrunch up any components on. Okay, well, it's just the LED anyway. I had to send an email to the Chinese conference today requesting an actual oral presentation. They gave me a poster after I asked for the former. I'm going to China just to stand by picture, right? Yeah, that's Well, fingers crossed. A little bit of a dick move to invite you to a conference without giving you the thing that you submitted, presumably. Wow, should I just wrap it up and go to bed because I'm fumbling so hard right now. I don't even know where the piece of wire pinged off to. Oh dear. Fingers crossed indeed. Yeah. Ugh. Hmm. Okay, it disappeared in the abyss. There, don't know the structure, but a 10-minute talk is miles better. Yeah. Okay, let's just use the copper wire instead. Do I need to burn off the enamel? So let me do that. That will do. Yes, that will reach indeed. And I don't need to fumble with the tweezers. Uh-oh. Okay. Get up. It was messing with my perspective. There we go. That's a decent joint. Sensitive is the board to mistakes. You can undo shit, but what's the point of no return when it comes to soldering a connection? Point of no return would be if you actually fry a component. Like there are some temperature sensitive components. You got your MOSFETs, you got well, I don't have any electrolytic capacitors here. Those can be quite finicky. But even then, like if it's a component that you can still replace, well, I mean, I guess, well, if I were to, for example, burn this chip here, that's the microcontroller. Which is exactly what I've done with this board, with the first prototype. Accidentally shorted something out, sent too high of a voltage into it, and game over. Yeah. But if barring that, like, yeah, I wouldn't want to damage anything on the Raspberry Pi board, because those SMD components are fucking tiny. These here caps and resistors right next to the microcontroller, crazy tiny. It's not really hand solderable. And I need to get some flux on this because that pin does not want to flow the solder on. Otherwise, the boards are fairly tolerant, I guess. I done some small stuff, but I'm terrified about excessive solder, for example. So there's a variety of other failure modes. For example, if you heat the solder pad or a solder pad on a circuit board too much, the copper trace can delaminate, which is no good because then the entire circuit board is basically garbage. And yeah, like too much heat can destroy things, for sure. Asking more in general. Yeah. Too much solder has the potential to result in like solder blobs bridging across traces, which can short things out where they shouldn't be. Which is why it's usually a good idea to keep the solder joints fairly tidy and use enough solder so that you have a good solid joint, but not so much that it starts to overflow to adjacent pads and leads. Like this, for example, is not enough because the solder, you probably cannot see it, but so the solder has flowed from this side, but not from this side. So it's not entirely surrounded the pad. But then what can happen is, yeah, I have a bit of an issue here. The these connectors are kind of finicky because the plastic melts very easily, and then they get out of alignment. Seems to be what happened here. So now I have a decent solder joint, but I might need to fix up the I probably should have soldered it on. Okay, it still connects. I'll just quickly reflow it. Maybe it will get nudged into the correct position. That's good enough. There's some tolerance always. What about this joint here? It's not very convincing. That looks a little bit better, but still. Gotta be good enough. Hard to capture all of the small stuff with the cam, but it's interesting. Yeah, that's all good. I don't mind. Oh, should I push this one out? Go back in, you little shit. Okay. This is a weird take on ultra numb. Okay, this doesn't float all the way. I think we're good now. Yes. That was fairly clean, but I'm still missing a tiny bit. I need to reach the Raspberry Pi because this is the 3.3 volt power line exposed from the Pi. Let's use another bit of copper wire. I'm gonna burn off the enamel. Okay, needs flux. And that pin was refusing to take on the solder. That's a lot better. Nice, beautiful. That's a fairly clean joint. It's kind of dirty because of all the flux, but that can be cleaned away. A little bit of isopropyl alcohol. Oh, fuck. Okay, I messed up there. Got a little messy, but I think we got it. Though I'm not sure about the adjacent. Is there a way to test it without hooking it up? Test function. You can test for shorts, which is something I probably will do. Okay, I butchered this one, so let's get it out. You know what? No, it's almost 3 in the morning. I should call it a night. I should get some rest. Got a long day tomorrow, so yeah, no, it's gonna have to be a wrap. And I will resume this next week because holy shit, I really need some rest. Yeah, after how much I butchered this last one. No, nope, it's bedtime. So yeah, whew, 6 hours tinkering with the soldering iron and component layout and all that. Fun. Actually, yes, fun. But yeah, until next time. Not sure if there's going to be any other streams this weekend. Depends on how well the painting goes tomorrow. So either Sunday, but almost certainly see you next week. And I'm going to try to get some shut-eye. Let's chat for a bit and have a nice... Yes, thank you. You too. Have a good night. Do I even want to raid someone? I don't know. I feel like I'm too tired for that even. All right. You know what? We're gonna raid Pally. She's playing Valorant. Pally's cool. Oh, she's actually doing a watch party. Yeah, that's soon over anyway. All right. See you next time. That's all. What the fuck are you doing? I want to stop this. Stop playing. All right. There we go.